Hi there, it's Dr. Maxwell here, and we're continuing with our topic of descriptive statistics. So, um, now we did previously talk about organizing and displaying data. Now we're going to talk about analyzing data. And there's two basic types of statistics that we get from our data. One gives us a measure of center, and one gives us a measure of variation. So measures of center tell you what, if it's numerical data, what's the average value. If it's categorical data, what's the mode, which one occurs most often. Measures of variation tell you how spread out your data is, how much variation there is in your data. So first, let's talk about measures of center. The first one is the mean, which I think we're all really quite familiar with, but maybe we haven't called it the mean. But like when I give you an exam, I'm interested in the class average. What was the average score? So the mean is the average value, and this is the sample mean, and it's represented by an X with a bar over it. And sometimes you might hear me say X bar, and I'm talking about the sample mean. Now, so here's the formula. You don't really have to memorize this. You just add up all your observations and divide by the number that there are. So N represents the number of data points or the number of observations. So that one's pretty straightforward, and we will look at some examples a bit later. The median might be new to you, and we talked about it at the end of the last lecture. It's the value in the middle, or if you don't have one exact value in the middle, you average the two values in the middle. So it's very important that you arrange your data in order. Smallest to largest is typical, but you have to order your data before you can find the median. Now, to find the median of the example 3 data, that's over here. Remember, that was the 14 students' uh, test scores. So N equals 14. Now, you probably realize that there is not going to be one number that it's exactly in the middle because we have an even number. This is what I'm trying to get across here, because sometimes you have a much larger collection of observations and you want to quickly be able to find a median. So you take N and you divide it by 2. It's either going to be a whole number or it's going to be something like K.5. So in the example 3 data, if we divide N by 2, that's 14 divided by 2, that equals 7. That's a whole number. So what does our rule say to do when you have a whole number? It says if the answer is a whole number, you will need to use the average of this value and the next. Whoops. So find the 7th observation plus the 8th observation and average them. That means divide by 2. And that's why after you get your initial stem and leaf plot, you put everything in order. So now I can quickly find the 7th observation. I just count 1, 2, 3, 4, 5, 6. Here's 7 and here's 8. So this will be 154 plus 155. divided by 2, which is, of course, 154.5. Now, this creates a new value. This is not in our data set, but this divides the data in half. Later, we'll talk about dividing our data in quarters, so it's important to understand what the median does. Now, what do I mean by this second part? If it's not a whole number, round up, and that value is the median. Well, excuse me, let's go this way. Let's look at this example, and now pretend that I have one more observation and see what would happen. So we'll call this example 3B. Suppose I had one more score, let's say 178. Then that would go here. Now, n is not 14 anymore. N equals 15. So, to find the median, we divide n in 2. And what is 15 divided by 2? Well, I think that's 7.5. Okay, this is not a whole number. What does my rule say to do? It says, let's clear this up a little bit. When it's not a whole number, you round up, and that value is the median. So if I round up, that would be 8. Now, this is not the median. Sometimes students think that is the median. No, this means use the 8th observation. So let's find the 8th observation. 1, 2, 3, 4, 5, 6, 7, 8. So the 8th observation is 155, and this is the median. And when you have an odd number of observations, there will be exactly one value in the middle. There are 7 scores below this and 7 scores above it. So the median is the value in the middle. Sometimes people get things mixed up. If you look at these two words together, maybe you can see median and middle. They kind of have something in common there. It might help you not mix it up with our next measure, which is called the mode. So the mode is the observation that occurs most often. And this is how I try to get students to not get it mixed up. Mode starts with M-O, most often. So find the mode of the example 3 data. Let's go to the original example 3. All right, find the mode. Well, look here. Let me maybe erase some of this. Now we're finding the mode. You want to see if there's an observation that occurs more than once, and sometimes you might have 2 modes. Here, there's one mode, and that is 155, because it occurs twice. Now, a data set might not have a mode. If the 155 score had not occurred twice, if every score was unique, then there would be no mode. If another score, like say we had 2 176s, then you would have two modes. The mode is most useful for categorical data. Like ice cream flavor. What was the favorite ice cream flavor when you did the survey? Or eye color, or hair color, or blood type. But we can talk about the mode with numerical data as well. Now, measures of variation. So it shows how much your data gets spread out from the center. So like you have your mean here, and sometimes you like to know how far away the other observations are from the mean. And sometimes instead of the mean, you will use the median and ask the same question. So here are 4 different types of measures of variation that we need to learn. And the first one is the range, which is pretty basic. But let's talk about this down here first. So what I'm saying here is we want to know how much variation there is in our data. And this is sort of a motivating example, because in each case, the mean equals 4. This is 3 data sets of 5 measurements. So n equals 5 for each one. The mean equals 4. But they're very different, right? So the mean tells you something, but you want to know something else. So how do these vary around the mean? Well, one thing you can look at is the range. That is the difference between the largest number and the smallest number. And sometimes people get this mixed up, but the range is always going to be a positive number. So what is the range of row 3? Well, the largest is 6, the smallest is 3, so the range equals 3. Row 4, every value equals, row 2, every value equals 4. So the range is 0. There's no variation. Everything is the same. And in row 3, you see the range is quite large, 10. So this tells us something. But the range is important, but it's not the most important measure of variation, but you usually do want to know it. So this is what we want to tackle next, deviations from the mean. We want to know, here's my mean, how far does the data go in either direction from the mean? So what we do is first we have to calculate the mean. So here are some test scores. There are 8 of them. So n equals 8. And if you calculate the mean, it's 81. So you add them all up and divide by 8. Now we're going to find the deviations from the mean. That means how far does each of these numbers differ from the mean. So we take each value, x sub I, and subtract off the mean. That's what this notation means. So the first value in my table is 72. So x1 minus the mean would be 72 minus 81. And that, I believe, is negative 9. So some of these are going to be negative because this is below the mean, and some are going to be positive because they're above the mean. So take each one and do this. 84 minus 81, well, that's positive 3. 96 minus 81, 15. 64, I get negative 17. 88 minus 81 is 7. 92 minus 81 is 11. 74 gives me a negative 7. And negative 3 for the last one. Now, what we would like, we want the average deviation from the mean. So it makes sense that you would add these up and divide by 8. But something really weird happens if you do that. So try it. So if you did it, you got 0. And that will always be the case. That's what this little notation says. And that's because of the mean is calculated based on how far away these are. It's just it will always be the case. So we can't use this to find the average deviation of the mean. So what's causing the problem is they cancel each other out. So this is what we're going to do. We're going to square these numbers and then add them up and try to get the average, and then at the end we'll take the square root, and that will give us what is known as the sample standard deviation. So this, okay, I had to do sort of a quick fix there, but hopefully you're looking at your handout. So the sample standard deviation gets the letter S, sample standard deviation. The S doesn't stand for sample, but what I'm pointing out is we'll see that this is different than the population standard deviation. This is from a sample. So it's calculated by first squaring all these deviations from the mean. So let's do that first. We square negative 9, we square 3, we square 15, we square 17, and 7, 11, negative 7, negative 3. And then you want to add all these numbers up. And if you do that, you should get 832. Now, so I need a little more room, so I'm just going to go over here. Our total is 832. So let's talk about this formula here. That's not our final answer yet, of course. Okay, so we did the squaring of each of the deviations. We have added them up, and now we're dividing by n minus 1. So why n minus 1? Students want to know. This is called degrees of freedom, which is a really weird term. But the way I make sense of it is this. We know the sums of the deviations are 0. So if you knew the first 1, 2, 3, 4, 5, 6, 7 deviations, you would automatically know the 8th deviation. It adds no information because you know what it is, because it has to make everything add up to 0. Also, it's because we've calculated the mean, and it's a very complicated thing. I like to think of it that way, that only n minus 1 observations really give you information. You get the last one for free. Now, you don't have to understand that. All you'd have to do is use the formula correctly. So what does this mean? This symbol here says add them up. That's a summation symbol. And it's called sigma, but you don't really need to know what that means. You just need to know what this formula is telling you to do. In here, that's the deviations from the mean. Here they are squared. This symbol says add them up and then divide them by n minus 1. So I have 832 divided by n is 8, so n minus 1 is 7, and then I'll take the square root. And so if you do that, your final answer is 10.9 if we round to one decimal place. So that is the average deviation from the mean. We call it the standard deviation. It gives you an idea of how your data is spread out from the mean. So you need to be able to calculate this by hand for a very small example. Sample variance is important, but we don't use it as much, especially in this course. It's simply the standard deviation squared. So instead of having the square root there, for this example, this would just be 832 divided by 7, which is 118.86. Now, the good thing about the sample standard deviation is this. Because we took the square root, S is in the same units as our data. Variance is used, sample variance and population variance is used more in further analysis of your data. You do analysis of variance. But for us, more important is going to be the sample standard deviation. But this is an important concept in statistics, and there are two formulas here that look very different. But actually in practice, the second one is easier to use if you have to do it. We won't have to do it. Okay. Now, I believe, yes, that's going to be, we're going to pause here. Next, we talk about something that for some people is brand new and a little difficult at first. So make sure you're in a good mood when you watch the next video. And I'll talk to you soon.